Our world runs on energy. For centuries, we have dug deep into the earth for coal, oil, and natural gas. These fuels have powered our homes and industries, but at a high cost to our planet. We now face a changing climate and an urgent need for cleaner energy sources. Scientists and engineers have explored solar power, wind power, and other renewables. Then something surprising happened. Geologists found pockets of almost pure hydrogen gas. This natural hydrogen found deep beneath the Earth's surface was a shock. Early reports spoke of potentially massive amounts. Hydrogen is the most abundant element in the universe. The excitement grew as more potential sites were identified globally. This discovery opens a new frontier in our quest for energy. The potential is immense, but so are the challenges. The journey ahead is filled with both excitement and uncertainty. The first hints of these vast hydrogen reserves were often subtle. In Mali, West Africa, a village well famously ignited in 1987 when a worker lit a cigarette, tapping into a natural hydrogen reservoir. This isolated incident was not widely understood until much more recently. More systematic discoveries began to emerge as detection technology improved. Scientists started looking for specific geological markers, like iron-rich rocks in ancient parts of continents or along mid-ocean ridges. In locations such as the Pyrenees Mountains, researchers deployed sensitive gas sensors to detect tiny traces of hydrogen seeping from the ground. The hydrogen appears to accumulate in underground traps, similar to those that trap oil and natural gas. Porous rock layers hold the hydrogen, while impermeable cap rocks prevent it from escaping too quickly. The discovery in northeastern France near the German border was particularly exciting, potentially holding millions of tons. These discoveries are the result of growing geological understanding and advanced science. Each new find fuels the hope that these underground hydrogen stores are more common than previously imagined. The scientific process behind the formation of this natural hydrogen is fascinating. One of the primary mechanisms believed to create this hydrogen is called serpentinization. It involves a chemical reaction between water and iron-rich rocks, such as olivine, in the Earth's upper mantle. When these rocks come into contact with water at specific temperatures and pressures, a transformation occurs. During serpentinization, water molecules react with the iron minerals in the rocks, forming iron oxides and hydroxides and releasing hydrogen gas. This process can happen wherever these iron-rich rocks meet water, often deep underground. The discovery of large, accessible reservoirs is what is new and exciting from an energy perspective. Understanding serpentinization helps geologists predict where to find these gold hydrogen deposits. This scientific understanding transforms the search from a shot in the dark into a more calculated endeavor. When we compare the extraction and use of natural hydrogen to traditional oil and gas drilling, the potential environmental benefits are striking. The primary product of burning hydrogen is water vapor, unlike fossil fuels that release carbon dioxide and other pollutants. Natural hydrogen, if extracted cleanly and efficiently, offers a path to energy with a much smaller carbon footprint. The extraction process could also be cleaner, with lower risks of large, polluting spills. Hydrogen disperses quickly into the atmosphere if it leaks, unlike crude oil. Natural hydrogen does not require the energy-intensive conversion processes that gray or blue hydrogen need. Green hydrogen is clean but currently expensive and requires vast amounts of renewable energy. Natural gold hydrogen, if abundant and accessible, could bypass these costly manufacturing steps. The potential to reduce our reliance on fossil fuels is perhaps the biggest allure. The buzz around natural hydrogen is not just academic. Several pioneering companies and research consortia are already taking action, launching pilot projects to test the feasibility of extracting and utilizing this newfound resource. In places like South Australia, companies are actively drilling exploration wells specifically targeting natural hydrogen. These early ventures are crucial, providing real-world data on extraction rates, reservoir characteristics, and actual costs. Governments around the world are also starting to take notice, funding research and supporting exploration efforts. The U.S. Department of Energy has programs aimed at understanding and harnessing geologic hydrogen. In France, the government has signaled strong interest following the significant discovery in the Lorraine region. These pilot projects involve comprehensive studies, analyzing the purity of the extracted hydrogen, and assessing the rate at which reservoirs might naturally replenish. The success of these initial projects will heavily influence future investment and development. The potential for energy independence is particularly appealing to governments looking to secure their energy future, while also meeting climate targets. The combination of environmental benefits and energy security makes natural hydrogen an increasingly compelling prospect. Despite the immense excitement, the path to harnessing natural hydrogen is not without significant challenges. One of the most immediate concerns is the flammability of hydrogen. Ensuring the safety of extraction, storage, and transportation infrastructure will be paramount. Another major question is the sustainability and renewability of these hydrogen reserves. The economics of natural hydrogen also need to be proven. Exploration and drilling are expensive, and the purity of the deposits will play a role. Finally, there are environmental considerations beyond just carbon dioxide emissions. A thorough life cycle assessment is needed to ensure that natural hydrogen is truly a net benefit for the environment. The discovery of potentially vast natural hydrogen reserves beneath our mountains and plains has certainly shaken the energy world. It presents a tantalizing prospect, a clean, abundant fuel source created by nature itself. This gold hydrogen could offer a pathway to decarbonize heavy industry, power long-haul transport, and provide a stable energy supply. However, the journey from discovery to widespread utilization is fraught with challenges. Safety concerns, questions about the renewability and true scale of the reserves, economic viability, and potential environmental impacts all need careful consideration. The initial enthusiasm must be tempered with rigorous scientific investigation and cautious development. The coming years will be critical, with pilot projects providing vital data. We need to understand if these hydrogen reservoirs are isolated pockets or part of a much larger interconnected global system. Natural hydrogen represents a powerful new tool in our energy toolkit, a source of hope. The search for sustainable energy is a complex puzzle, and natural hydrogen might just be one crucial piece.